Hi again. So this is part 2 of the example problem. If you haven't tried this yet, so please stop this video and go back and do it your own. I want you to give it a try at least. If you've done, then please let's just do it again together the second time. So it's very similar to the first part, but the numbers change, so we'll see how things changed. But I'm going to a little bit more quicker on this because I've shown some of the things in the first part. I may not show all the details, okay? So I'm assuming you checked the first solution already. Okay, so let's start with the free body diagram. You already know what the problem is about, and again, we do not know which way it's moving. If it is moving, we need to figure it out, and we will find the direction of the acceleration of the system and also the magnitude and its frictional inclined surface. So if we focus on M1 again, I'm just gonna draw the free body diagram here. Okay, so we have M1. Once again, we have W1, normal force. There's tension force. And just like before, I'm going to take X and Y the same direction. Okay, for no reason really. And once again, I don't know which way the friction is, so I'm gonna think about this later. For M2, we have tension force upward, and there's weight force downward. Okay, and again, I'm gonna be consistent with my X and Y. Let me fix this quick. This is X. So it's up the incline for the M1 is positive X. I'm following the rope line. It is down. So for M2, it's one dimension, and X, I'm going to label it as downward. Okay, it's positive. That way I made if there's any acceleration, I made them the same direction. I just don't know if I chose the right direction, and we'll find out. Okay, so if the system is released, we'll find out the direction of the acceleration. So I'm going to do similar things. If you remember, I did split this into components because the rope line is what matters. Okay. So if I focus on the rope line, W1X and T is for M1, and also friction, but I don't know what the direction yet. And for M2, T and W2 are what matters for now. So let's, as we did before, let's find out what W1X and W2 are. So W1X is M1G. Once again, this is our theta inclined surface. Okay, so sine theta. And again, I'm not going to plug the numbers in this time. When you do so, 9 kilograms times 9.81 meters per second squared times sine 30, you will get 44.15 newtons. Okay. Even if I do the same thing for W2, it is M2 times G. And what I'm getting is M2 is 1.5 kilograms and G is 9.81 meters per second squared. So the answer is 14.72 newtons. Compared to the previous part, what you see is W2 is much less than W1X, right? That means if it's gonna move, it might move down the inclined surface, not up the inclined surface, right? In this case, it's a little different. But what is the difference? W1X is bigger this time, minus W2. I'm getting the difference as 29.43. Just to check with my maximum static friction, okay? Just like before. So what is maximum static friction? Fs max is mu s n1. And just like before, we find out that N1 is M1G cosine theta, because M1G cosine theta is W1Y, right? Again, I showed the solution to that on the previous question, so please check the y-axis second law equation. And that gives me 22.94 newtons. So what I do next is I compare the difference between those horizontal components or those x components with the maximum static friction. This time, this is larger than this maximum static friction. What does that mean now? In the previous problem, it was slightly less, right? So it couldn't even move. Now there's enough force to overcome the friction and even accelerate. So since it's going to be moving, we won't have static friction, first of all. So that would bring us, first of all, because of this, we can say it is moving, right? It's even accelerating. So if it is moving, then I have to consider kinetic friction. That would be mu k times N1. And if we find that out, again, N1 is once again M1G cosine theta using mu k value. Gonna make this also quick. The answer should be 11.47 newtons. So now if you think about the free body diagram, just like kind of try to see it along the x direction. Okay, so we said that on the incline going down, right? That is my x-axis. So what are the forces along this line? For M1, right here, we have W1x downward, and for M2, we have W2. So which way is friction? We figured out that there is kinetic friction because it's moving. It has to. There's enough force. And because W1x is much larger than W2. So if it is moving, it's really moving opposite direction of positive x direction that I chose. So this is the acceleration direction for the objects, okay? Since the intended motion is down the inclined surface, friction is going to be up the incline. So I'm gonna say for the system, sum of Fx equals to total mass times Ax. So when you use capital M, it usually means that it is a total mass. So I'm really saying this is M1 plus M2. So what is sum of x? Since I chose the negative x to be the acceleration direction, I gotta be careful, but I'm gonna keep my axes. So up the incline is positive. That means it's negative W1x, positive Fk, right? And we have also W2, and that becomes positive according to my chosen x-axis, positive x-axis. That's equal to mass times acceleration. Ax becomes A because that's the only acceleration that we have. So from this we can solve for MA. We already know that W1x minus W2, right? We wrote that down, and we know what is F2. So not F2, Fk. Fk is, so I'm gonna kind of write this first, 11, right, Fk 11.47 newtons is what Fk is. And the rest is, we find out up here, again, right here, this value is W1x minus W2. So if I want to write down W2 minus W1x, I need to write this negative of this, right? And that's what I'm going to do. Let me go down first. And that is negative 20. 9.43 newtons, right? So I already combined W1x minus W2, that's what it is. And that's equal to total mass is 9 plus 1.5 kilograms, so it's 10.5 kilograms. And times A. Since newtons is kilograms per meters, kilograms times meters per second square, kilogram will cancel out and we will get the acceleration in meters per second square. But what we're getting is a negative acceleration, as it should, because we chose the wrong direction. But it is okay. Right, so if you look at this, when it is asking for the direction, now we can say what the direction is, right? Because the chosen x positive x direction is the wrong direction. So you can say that because this is negative, M2 is going up, right? And M1 is going down the incline. And what is the magnitude? 1.71 meters per second square. Okay, I hope that's clear. And again, it's really important that we don't make wrong assumptions. We start with the figuring things out, if we have enough forces to overcome static maximum. And then if there is, as we had it in this problem, then we go back and then say, okay, I have enough force. That means I already passed on the verge of moving. It's already moving. That means I have to use kinetic friction this time. So when I use it in my equation to find acceleration, I have kinetic friction for that reason. Okay? Hope this is helpful.